Welcome to Mr. V Teaching Math. In this session, we're going to look at one of the challenges students run into with calculators. If we're working with very large or very small numbers, like this, let's say I have my entire screen filled with 8s timed my entire screen filled with 8s, I'm going to end up with a number like this. A number of students are going to look at this and go, 7.9? What? That's not the answer, because I just did 888,888 times 800. It should be a really big number. What your calculator has a limitation. It only has so many digits it can fit on the screen. So what it's done is it's taken a short form. This is scientific notation. You can watch an earlier video for exactly how scientific notation works. My calculator, a slightly older model, has taken a shortcut. This is actually 7.901234566 times, and here's what the shortcut. It left out this, times 10 to the power of 19. There's just a 19 there, but the times 10 is left out. It's an older model. At that time, the technology wasn't so great, so they had a hard time including that. So you have to watch out for that. Many times, they're going to leave that out. So I'm going to use this same question on a couple other calculators to demonstrate exactly what it looks like. If you want to learn how to turn that into the actual answer, go watch my other video on scientific notation. So, here we go again. Same problem. The answer is slightly different. I may have actually not pressed as many 8s. But here we have the same thing that my calculator is doing. It's leaving out the times 10 part. Next model. Again, same thing, leaving out the times 10. Now this calculator is interesting because see how I'm pressing 8 and it's going to fill in a whole bunch more. It's a newer model. It's much more powerful than my old one. Notice what it's done. It actually has the times 10 in there. And it actually, notice it's 43 this time. That's because I was still pressing the 8s. This one has memory and it's recording everything I punch in. Much more powerful than my old one. That's important to notice. The times 10 is in there. This is a much better model. Again, same thing. Now this one is a little different. In the earlier ones, it kind of made the number smaller. If you go back and look at my original one, when I did this, it makes the number smaller, so it's easier to recognize that that is the power of to the power of 10. All this one does is leaves a space. So you have to be alert and watch for this. This is not 7.9012345519. There is a times 10 to the power of 19 right here. So you have to be really alert and watch for that on some calculators because that's the way some of them will work. Another example. Again, this one has memory, so as I'm pressing all these 8s, it's filling up, it's going way beyond what's on the screen. So this is going to end up with a much higher number. Oh, nope, I'm wrong. It actually doesn't. This one doesn't have extra memory. But it does have the times 10 showing, so that's good. Another model. This one has lots of memory, and it is also showing the times 10. That's another rather good calculator. Again, this is one of the ones that doesn't make the number smaller and just leaves an empty space. It still works fine. You just have to remember that there's a times 10 here and don't miss that space. This one is doing the same thing. Now it only goes up to 15, but that's because it has less digits and it's not holding as much on its screen. This one has room for more digits. This one will hold 10 on the screen. This one's only holding 8. I think it's 8. Yeah, 8. Okay, so just remember, there's a times 10 here that it's not showing. Last of the different models I have to work with today. We'll see how much, if this one has any memory as well. No, it doesn't have any extra memory. It only does what's on the screen. But again, it leaves out the times 10. At least it makes the numbers smaller. But you have to watch out for each of these calculators. And when you see something that has a decimal, watch out here at the end to see if it is or is not an exponent. Now, it can also end up with, oops, it's also possible to end up with negative exponents. That didn't work. What did I do wrong? Oops. How about I do something else? 5 to the power of negative 2. Whoops. 5 to the power of 2, make it negative. There we go. Let's do 8 to the power of 25, make it negative. It is possible to end up with negative exponents. You want to watch for those as well. Okay? The other ones will show negative signs in different places. The best calculator I probably saw of the set I had today was this one. It has lots of memory. It shows all the numbers nice and clearly. But that is what to watch for when you're dealing with a calculator, and it sometimes shows scientific notation.